Good morning. Are you excited to do some delta math and really delve into the world of exponential functions? Well, Queen Kessous is here to help you. I have my trusty little Dia de los Muertos sugar skull here, which will bring us much luck and much exponential brilliance. We are going to be working today on exponential equations. So this unit, if you want to make money in your life, this is the most important unit you are going to learn in 4 years of high school. Compound interest and exponential functions is essential to investing money, to making money, to every financial decision you're going to make. Buying a car, buying a house, all of these things are based on this unit. So pay close attention. All right, so let's say we're going to start with just the basics of things. We want to write an exponential equation from a table. So I'm given a table. The first thing is, what does an exponential equation look like? So I need to know what it looks like, and that is an exponential equation is in the form y equals a times b to the x power. This right here, a, is my initial value. So that's my initial value. Okay. And b is my growth factor. So growth factor is what you multiply by. So that's what you multiply by. That's important, so write this all down. If you need to pause the video to get this, that's important. The last thing is the x. The x is always a variable in the exponent, and it almost always stands for time. So in this case, it's how long are things going for, the amount of time that has passed. Okay, so take a second, pause that, write it all down, and then we're going to move on. Slide that down, make it a little easier to look at. So the first thing I want to do is find what is it multiplying by each time. Because in exponential functions, we don't add every time. It's not that straight line of $1,000 a day. It's multiplying each day, just like when we doubled the penny and you times it by 2 every day. Remember how fast it started to grow after a while? So we need to find what is it multiplying by. Sometimes it's really easy to see. So you're just looking here to see what is it multiplying by to get from 4 to 12, to get from 12 to 36, and to get from 36 to 108. So if you can see right away, oh, it's multiplying by 3, you got it. Now let's just check. We do 12 times 3 in our calculator, and it gives us 36. And 36 times 3 in our calculator gives us 108. If it's not so easy to tell, all you have to do is take a y2. So remember, this would be like x1, y1, and x2, y2, right? Just like in regular linear equations. So we would take the second number, the 12, and we would divide it by the y above it, the 4. And 12 divided by 4 gives us 3. You could have done that with any of these. So you could take the 36 right here and divide it with the one that came right before it. And you'll also get 3. So the 3 is the growth factor. That's the first thing. It's much quicker than when we're doing linear equations, right? Then I want to find the initial value. Sometimes it's super easy because the initial value is where you start, and that's when x is 0. That's at the beginning, right? When no time has passed. So when x is 0, my y is 4. So this right here, whenever x is 0, 0, 4, that means that my initial value is 4. Okay, now all I'm going to do is plug it into this equation up here. So to do that, I'm going to write out my equation, and that is going to be y equals, because it always has a y and an x in it. My a is my initial value. Initial value is 4, so I put that right here, times b is the growth factor. Growth factor is 3, put that right here, and the exponent is x. And that's it. That's how you write your equation. Let's do one more just to make sure we understand it. Pause it, write everything down, and then stay with us. Okay, so we want to find the growth factor. So we're looking to see what is it multiplying by each time. Sometimes it's really hard because sometimes it's going down. That is called decay. Decay is when it decreases, and we want to find what is it multiplying by to make it decay like that, to make it go down. So again, we're going to take our y2, okay, and just divide it by the number that came before it. So I'm going to take 2.5 and divide it by 5. And I put that in my calculator, 2.5 divided by 5, and it gives me 0.5. I'm just going to check with another one, because remember, you can do this with any of them. So I'm going to take another one. Let's say I take the 0.65, and I'm just going to divide it with what came before. So 0.625 divided by 1.25. It's always the one that came right before. y2 divided by y1. So I do 1.25 divided by 0.625 in my calculator. And, no, sorry, 0.625 divided by 1.25. And it gives me 0.5. It will always work. So that is my growth factor, 0.5. Initial value, all I have to do for my initial value is look to see where is the x0. That's it. So initial value, so the initial value equals 5. Now I write my equation. Y equals, initial value goes first, so that's 5, parenthesis. Growth factor goes inside, 0.5, to the x power. And that's it. Done with that. So that's how we would come up with the exponential equation from a table. The next thing is, this is just a review. What do exponents mean? What do they mean? So a to the fourth, well, it means that you're multiplying a 4 times. That you remember from elementary school. So I'm going to write that out. 1, 2, 3, 4. That's a to the fourth right there. Okay? Then multiply, so I'm multiplying again. A squared, that means a times a. Okay, cool. A times a, that's really just a squared. So how many a's are being multiplied all together? So I'm looking to count how many a's are being multiplied all together here. 1, 2, 3, 4, 5, 6. There's 6 a's, so the short way to write that is a to the 6th power. Because there's 6 a's being multiplied, that's what a to the 6 means. Cool, that's it. That's the simplified version. X to the third, that means x times x times x. Okay? X to the fifth. 1, 2, 3, 4, 5. Awesome. How many x's are being multiplied all together? 1, 2, 3, 4, 5, 6, 7, 8. That is x to the 8th power. And that's my simplified version. That's all you have to practice today as we explore and really think about how pandemics, and especially the COVID-19 pandemic, is modeled by exponential growth, and how understanding and learning this can help scientists and America and the world deal with pandemics in the future better than we did this time. Enjoy this, learn a lot from it, take your time, pause, take notes, and have fun. Bye.